Hi, welcome to lesson 2.4, Algebraic Reasoning. Now, before we start with the journal, for those of you that are my students, please make sure to check on Teams in the folder where it says Files, then Classroom Materials, and there should be two documents in there that look like this. The first one's called Properties of Real Numbers. It looks something like this. Okay, I'm not going to take time to go over these. You guys need to download them first before you guys do the lesson. And the second document looks like this. Okay, so please make sure you download them, make sure that you study them and understand them, as I am going to be referencing to these properties in the videos. Okay, so pretty much they're just the properties of equality, the distributive property, and some basics on properties of congruence, as well as some properties of real numbers that you should have learned in middle school, okay, or in Algebra 1. So the commutative properties of addition and multiplication, the associative properties of addition, the associative property of multiplication, the distributive property, the identity property of addition, the identity property of multiplication, additive inverse, multiplicative inverse, and the property of zero, or the zero product property. So please make sure that you familiarize yourself with these properties before you start the lesson. Okay, so this is kind of like our first introduction to proofs. Okay, now like I said, you're not going to like proofs, okay, but it is something that we do need to learn how to do. All right, so let's take a look at what exactly is a proof. A proof is like kind of like a sequence of justifications that, you know, like for example, you're trying to solve something, you end up with an answer, but in between there's a lot of rules that you use, but you just never really say what the rules are. So here we are going to be doing that. Okay, so the easiest proofs are the algebraic proofs, and here's an example of one. Okay, you have this algebraic equation. It's 2 times parentheses x plus 3 minus 5 equals 5x plus 4. So the first step is they applied the distributive property. You can see here that they multiplied the 2 and the x and the 2 and the 3 to give you 2x plus 6. Once they did that, you can see that they combined these two, they simplified to give you a 1. Now from here, to solve for x, they subtract 2x on both sides. Normally we write the minus 2x at the bottom. They wrote that within the same whatever it's called, not sentence, but within the same line. So subtract 2x from both sides. That gives you 3x. These 2x's subtract out to give you 1 equals to 3x plus 4. Then you minus 4 on both sides, and you get negative 3 equals 3x. And then you divide it by 3, you get x equals negative 1. But for some reason, they want the variable on the left, so then they flip them to x equals negative 1. Okay, so we solved it for x. Now what we got to do is go back and justify every single one of those steps. Okay? All right. So let's take a look at the very first part. The very first thing that they did here was use the distributive property. Now I'm going to be numbering these just so that we know what we're talking about. So we're going to call this one here step 1. Step 2, step 3, step 4, 5, 6, 7, 8, 9, and 10. That way, you know which step I'm going to be doing. So the first part is always the given, is what you start off with. So what was the first thing that they did here? Well, they distribute the 2 into the parentheses. So what was the property? This is called the distributive property. Eventually, guys, when we do proofs, I'm going to be abbreviating, okay? So it was a distributive property. Now, what ended up happening here was after you distributed, you had 2x plus 6. Now the 6 minus 5, that got combined, it got simplified. We even though it says that we did a subtraction, we didn't do a subtraction on both ends. So what we did is we simplified and ended up with a 1. Okay, so what we did is we simplified. Or if you just write simplified, it's okay. You don't have to put simplified. We simplify. So now the next step, as you can see, is we subtracted 2x from both sides. Now, because I did that to both sides, we're going to say that this was the subtraction property, I'm going to abbreviate, of equality. Subtraction property of equality. So within that subtraction property of equality, we are going to simplify this. Okay, so that's going to give me 0 for this and 3x for that part. So we're going to simplify. Now keep in mind, I'm showing every single little step. Eventually, we're going to be able to do this with a lot less steps. Okay, in the next part, we subtracted 4 from both sides. So again, we are doing the subtraction property of equality. Okay, subtraction property of equality. Now, when we subtracted, we ended up simplifying. Okay, so we simplified. Now, from step 7 to step 8, we are going to divide by 3 on both sides. So we call this the division property of equality. And of course, we simplified. Now, if it were for me, I would stop there, but they want the variable on the left-hand side. So what they did here is they did what we call the symmetric property of equality. Okay, so that's the symmetric property of equality. All right. So now where am I getting all of these properties, guys? They're in the ones that the first two pages I showed you at the beginning of the video. Please make sure that you have those handy, okay, or at least have them accessible. If we were in class, I'd give them to you, but you know, obviously we're not there. All right, let's turn to page 50. Okay, so here we need to figure out what the name of these properties is going to be. So all we know is that you're either going to have a circle or a square that's going to represent addition or multiplication. At this point, we don't know. Okay, now let's look at something. 5 diamond, so it's a square, diamond, same thing. I'll call it diamond. 5 diamond 6 equals 6 diamond 5. So we got to check to see if this works with both multiplication and addition. 5 plus 6 does equal 6 plus 5. And 5 times 6 equals 6 times 5. So here we know it's going to work for both. But I know for sure that this is going to be the commutative property of, I don't know. We'll have to come back and figure that out. Same thing for this one. Now, honestly, I don't want to be writing the big old word commutative. I'm just going to abbreviate it. Okay, commutative property of, we don't know. We don't know if that's addition or multiplication. Now, this next one, you have 4 either plus, parentheses, 5 plus 6, does equal 4 plus 5 plus 6. Or if this was multiplication, we know that's going to work. So I know for sure this is going to be the associative property of, we don't know yet. We'll figure it out. Okay, same thing for this one. Maybe the next one's going to help us figure out whether what's addition, what's multiplication. So let's see. Let's assume that this is addition. 0 plus 5 does not give me 0. So I know that's not going to be addition. Let's see if it's going to be multiplication. 0 times 5 does equal 0. Okay, so we figured it out. This is multiplication, and this is going to be addition, because 0 plus 5 is 5. Okay, so to name this one, this is going to be the property of 0. Okay, or sometimes it's called the zero product property. Okay, Now for this one, when you're adding nothing to a number, you're adding 0 and you get the same number, we call that the identity, if I can spell identity right, identity property of addition. Okay, so we can go back here and add what we already knew. Okay, I mean, we already just found out. So this is going to be of multiplication. This is going to be of addition, multiplication, and addition. Now that we know what those are going to be. Now, on this one, since we know that this is going to be multiplication, a number multiplied by 1, it's itself. So we call that the identity property of multiplication. And for the last part, you notice here that we know that this is multiplication, we know that this is addition. So if I were to like rewrite it, 4 times, normally we won't put the times because we would just use the parentheses. Okay, this is the same thing as 4 times 5 plus 4 times 6. So to me, this looks like the distributive property. And yes, it's of multiplication. Okay, so it's going to be the distributive property of multiplication. All right, so let's go over some of these algebraic properties. Okay, so I want you to turn to page 51. And yeah, we don't need these here at the bottom. Anything that I don't do, guys, don't do it. All right, so you're going to have number 1 here, where it says equation. Number 2 is going to go down here at the bottom. Now, algebraic properties of equality. Okay? These are the rules of like what you do to the left, you do to the right. If you add on the left, you add on the right. If you subtract on the left, you subtract on the right. If you multiply on the left, you multiply on the right. If you divide by a number on the left, then you got to divide by a number on the right. Okay? So these are the rules that allows us to solve for equations. Okay? The first one's called the addition property of equality. Okay? Very technical. All it says that if you add a number on the left, you got to add a number on the right. Okay, subtraction property of equality. If you subtract a number on the left, you subtract a number on the right. If you multiply for multiplication property of equality, if you multiply on the left, you got to multiply on the right. In division property, if you divide by a number, you got to divide the other side too. The only restriction is you cannot divide by 0. Now, substitution property of equality. If A equals B, meaning that it equals like a number, then A can be substituted for B in any equation or expression. Okay? This is what allows us to solve for many things. Okay, turn the page to 52. Okay, and here is the distributive property. Okay, so I don't really like the one for the difference. I don't think it's really that relevant. I like the one for addition because if that's a minus sign, you just got to figure out that's there's a minus sign there. Okay, so A times B plus C is equivalent to A times B plus A times C. And if that's a minus sign, then that should be a minus sign. And just be careful, your signs can change depending on what these numbers are, whether positive or negative. All right, now here are the fun ones. Reflexive, symmetric, and transitive properties of equality. Okay, so let's take a look at a few of these. Okay, now the ones that we just learned or we already knew about are these right here. Okay, so you have the reflexive property of real numbers, meaning that a number is equal to itself. The symmetric property, if A equals B, then B equals A. Okay, transitive property, if A equals B and B equals C, then A equals C. Okay, so these right here, they're not new. You learned these back in middle school. Okay, now these are all in reference to real numbers. Okay, now segment length and angle measurements, those are also real numbers, but they're specific to segment length and angle measurements. So for example, here are the ones for segment length. Okay, and here are the ones for angle measures. I don't know if you can see yellow. Okay, so they work like this. Okay, the length of a segment is equal to itself. If the length of segment AB is equal to the length of segment CD, then the length of segment CD is equal to the length of segment AB. If the length of segment AB is equal to the length of segment CD, and if segment CD is equal to the length of segment EF, then AB is equal to EF. Now, all of these can be proven using these right here. The measure of an angle is equal to itself. If the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. Okay, that means like you can switch them. If the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A is equal to the measure of angle C. Make sure you guys get very familiar with these because you're going to need to know how to apply them. By the way, number 4 goes right there, and 3 goes right above there. Okay? So we're going to go ahead and get started with our examples. We have 4 examples to do. Okay? All right. So you already know where they go. All right, here's example number 1. Okay? It says solve and justify each step. All right, so what we're going to do is I always like to just solve this out and then justify my steps. Okay? So you have your given, it's 3x plus 2 equals 23 minus 4x. Okay, that is what is given to me. All right, so what I'm going to do is I'm going to get rid of the term that is the smallest, that has the smallest variable. So for example, this one, not variable, coefficient. So what I'm going to do is I am going to add 4x, but I'm going to do it the way the way I normally do it. Okay, I'm going to add 4x to both sides. Okay, so when I simplify this, I'm going to get, not 3x, I'm going to get 7x plus 2 equal to 23. Okay, so what did I do from this step to the next step? I used the addition property of equality. Okay? Now the next step is going to be to subtract 2. And I get 7x equals 21. So what did I do? I used the subtraction property of equality. And then the next step is to divide by 7. And x is going to give me 3. So what did I do? I used the division property of equality. Now, if you look at your textbook, you're going to see that there are 2 steps that I did not include. Simply because it's not really that necessary to be including every time you simplify something. It'll make your future proofs a lot longer. So here I made like a 4-step proof rather than a 6 or 7-step proof. Okay, if you can take little shortcuts and still give me the right justifications, it should all be just fine. Okay, so that is example number 1. Okay, let's take a look at example number 2 now. Okay, example number 2. It's more the same thing. It's just really involving the distance formula. Not the distance formula, but the distributive property. Okay, so let's just start. That's going to give me -5. 7w plus 8 equal to 30. Okay, and that first step was given to me. Okay, I'm going to use the distributive property. Okay, so what did I do? I used the distributive property. Okay, you don't have to put a multiplication. All right, so next thing we're going to do, we are going to add 40 to both ends. That's going to give me negative 35W equal to 70. And what did I do? I added on both sides. So that's the addition property of equality. Remember, our goal is to justify every step, not just solve for it. I know we in algebra, we got spoiled because we just solved it and we never really justified anything because we kind of assumed that, oh, I know what you're using. But in geometry, guys, we need to justify absolutely everything. Okay, so W is going to equal negative 2. And what did we do? We used the division property of equality. Okay? So if I'm going a little fast, guys, pause it so you can, take your notes. Okay, so that's example number 2. Let's go to example number 3. Okay, so for example number 3, here's what we're going to do. Okay, it says you get a raise at your part-time job. To write your raise as a percent, use the formula that's provided there for you. It's P times R plus 1 equal to N, where P is your previous wage, R is the recent, is the percent increase as a decimal, and N is your new wage. Solve the formula for R. Okay, so here's my equation. Okay, you have P times R plus 1 equal to N. Okay, and what I need to do is solve it for R. Okay, there's many ways that you can do this, guys. Okay, so what I'm going to do is I am going to distribute. That's going to give me, PR plus P equal to N. Okay, I'll come back to the steps in just a second. Okay, I'm going to minus P on both ends. That's PR equal to N minus P. And then divided by P on both sides, that's R equals N minus P over P. Okay, so first step I did was distributive property. Next step was the subtraction property. And of course, of equality. Okay. Then the next step was the division property of equality. Man, my writing is getting worse. Okay, now that just answers the first part of the question. Now it's asking me, what is your raise written as a percent when your hourly wage increases from $7.25 to $7.54? So the rate. Now your new wage is $7.54. Your previous wage is $7.25. All you're doing is literally just substituting the values. Okay. Now what I'm going to do is I'm going to simplify this. That's going to give me 0.29. You got a 29 cents raise. After taxes, you're not going to get jack. Okay, so when you divide this into the calculator, you're going to get 0.04. Now that's the equivalent to a 4% raise. Okay? That is not a good raise, but it's better than nothing. Okay. All right, that's question number 3. Okay, question number 4 is a little bit more complicated. Okay, so let's look at question number 4. Okay, so let me see if I can zoom in a little bit. Okay, so it says you reflect the beam of a spotlight off a mirror lying flat on the stage as shown. Determine whether DBA, okay, now you could barely see it, guys, but technically this is point D. Okay, that's point D. And this one right here is point E. My picture didn't come out that well. Okay, so they want to know dBA equal to EBC, and that's what I need to show. Now, according to this diagram, what I'm given is that the measure of angle 1 is equal to the measure of angle 3. Now, why is that? Well, it's marked in the problem. So technically, it's given. Okay. So now let's take a look at dBA. dBA is made up of two angles. Okay, so dBA is made up of angle 2 and angle 3. So I know that the measure of angle dBA is equal to the sum of angle 3 and angle 2. Okay, and the reason why that's true, that's because of the angle addition postulate that we covered in chapter 1. Okay, so now here's the thing. Check this out. Okay, what does the measure of angle 3 equal? Well, the measure of angle 3, according to statement number 1 up here, is equal to the measure of angle 1. So what I'm going to do is I'm going to substitute. I'm going to put the measure of angle 1 in its place. Okay, so what did I do? I did a substitution. Okay, now what am I trying to show? I'm trying to show that this right here is true. Okay? Okay, so now here's the thing. Looking at the diagram, we know that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle EBC. Okay? And that is the angle addition postulate. Now, here's the interesting thing. Do you see how this and this, they're the same thing? Okay? So if these two are equal, then that would make this and this equal to each other. So the measure of angle dBA equals the measure of angle EBC. And what this is called the transitive property of equality. Okay, so this is kind of like a proof. Okay, if I want to do a proof, all I would have to do is just put a little 2 column in there and number these, and that will be my proof. As a matter of fact, this problem will be coming up later on. Okay, so that's example 4. Okay, we are not doing sample 5. I don't think it's a relevant problem. So please make sure that you are completing your extra practices, and we will see you in the live instruction. Have a great day.